minus 3y to the power of 4. Okay. Just kind of a review from yesterday. You wouldn't necessarily tough to expand this on your own. So you start by writing the first term to the power of 4, the second term, including the sign, to the exponent that makes the sum 4, right? And so then it's 2x cubed. And then you just keep going. You kind of go down on one side and up on the other. And then there's these coefficients to deal with that come from Pascal's triangle. And hopefully if you did any review yesterday, you at least tried to write this out on your own. We got to go one more line because we need 5 coefficients. So 1, 4, 6, 4, 1. And then you just have to simplify each of these. Okay. So 2x to the 4th is 16x to the 4th. Anything to the 0 power is 0. So that's nice. Usually the first and the last aren't too bad. The in-between ones are ones where it gets a little difficult. 2 cubed is 8 times negative 3 is negative 24 times 4 is negative 96 x cubed y. You'll also kind of start to notice a pattern there, especially when there's 2 variables. You'll see some things there with that. The next one here is 4x squared times 9, 36. 4 times 9 is 36 times this 6. The order doesn't matter how you do it. What 36 times 6 I think is like 216. Might be good to double check that. Then you got 2 times 27, that's 54 times 4. So you can see the biggest challenge I think is actually the multiplication of the coefficients. That's also 216. Should be negative though. They alternate in sign. And then the last one here is 81 y to the 4th, like that. That's kind of your starter question. Your final answer, 16x to the 4th minus 96x cubed y plus 216x squared y squared minus 216 xy cubed plus 81 y to the 4th. So, is that clear? Any questions on that?
Um, no.
Okay.
Yeah.
So here's how your instructor makes this more difficult. They might call this the first term, the second, the third, the 4th, and the 5th. There's always one more term than the exponent. So let's say your instructor wants something crazy, like I don't know, negative x plus I can't make these too big. Let's go 1/2 y to the power of 9. Okay, and they wanted the instructor wanted the 8th term. Okay, so what you don't want to do is you don't want to do this list like we just did. That's not going to work. What you want to do is be like, well, what's the 8th term? Well, the 8th term is minus x to the 8th. Sorry, not 8th. Sorry. 1/2 y to the 8th. Okay, minus x to the 1, and then grab the coefficient. Now, the coefficient can be done differently than we've been doing. Did you guys? Well, you haven't even had class yet. At some point, you may learn this thing called combinations. You maybe saw it in previous class, NCR. Have you seen that before?
Don't think so. Maybe if I did, I probably would have forgotten.
Yeah. So for now, let's not talk about that for now. For now, let's just look at at a um at a Pascal's triangle. Let's see if we can go find the 8th row or the 9th row in this case. 8th row. We're starting at row 0. So 1, 2, 3, 4, 5, 6, 7, 8. Wow, so this one doesn't even have them all. Okay. All right. I think I grabbed this image yesterday. So the issue is that coefficient. All right. And we talked about this idea that you start at row 0. So 0, 1, 2, 3, 4, 5, 6. This is 7, so we need to go one more. 8, 28, 56, 70, 56, 28, 8, and 1. Now, since we're doing the second to last term, we want this 8 right here. What do you think of this, what we've done so far?
So whenever it's two variables to like the that have different exponents, you take the larger one.
No, it's like the eighth term. Like the first term this is the first term. The first one to the power of 4, the second to the power of
Yeah.
0, and you go like that. There's other ways the instructor could ask for it, which we'll discuss. But the eighth term typically refers to the one that's it refers to this idea that the first thing, like X, is the leading one, and then Y is the second one.
Uh,
So, the reason you get a problem like this is they don't want you to expand the whole thing. They just want to know if you can find a certain term. Okay. So so you could simplify this, right? Like it's not great, but it's possible. 8 is really 2 to the power of 3. Okay. And then this is minus X 1 over 2 to the 8th, Y to the 8th. So the 2 to the 3rd to the 8th cancels to 2 to the 5th. And so you end up getting 1 over 32 negative, and then X and Y like to the 8, like that.
got it. So basically multiply the negative x into one or the negative to one and then
Yeah.
simplify the two to the fifth.
Yeah. So let's do the same thing, but this time, since we got it up, let's say we wanted the third term. Okay. So the third term is, and it's easier to start with the second one. It's 1/2 y to the power of 3. You'll notice that in the terms, the uh the second one tells you, I'm sorry, I messed this up already. Um, why did I do that? First, second. So the third term, I think I actually did this wrong. No, I did it right. No, I'm sorry. I messed this one up. This one, everything I just said refers to the ninth term. I apologize. So the third term, let me go back to this. This is why this is so confusing. 0, 1, 2. So the first term is to the power of 0. Second term is the power of 1. Third term is the power of 2. So you have to remember that sort of it's like subtracting 1. So it really means that this is to the power of 2, and the other one is to the power of 7. It's always minus 1 because the first one starts at 0. It's an indexing problem. And then you still grab the third number here, so 28, like that. So 28, this is minus x to the 7th, and then it's 1/4 y to the 4th, and then it ends up being -7 x to the 7th y to the 4th. No, I don't know. Squared. Why am I, it should be squared, not that. Okay. All right, so we're gonna reset here and try some that are slightly easier. Another way that they might actually present this. Let's say let's say they ask you to do something like x plus 1 over x to the power of 5. Okay. So this is kind of going backwards to what we were starting with. So it would be x to the power of 5. Now this 1 over x is really x to the negative 1. These are common problems you might see. And then you still have that coefficient. This is x to the 4th, x to the minus 1 to the power of 1, and so on. So this becomes x cubed, x to the minus 1 squared, x squared, x to the 1, x to the 0, x to the minus 1 cubed, x to the minus 1 to the 4th, x to the minus 1 to the 5th. And then you need the coefficients here. So if you go back to Pascal's triangle, which I'll just copy in here. Oh, huh. Why didn't that copy? Copy image. There we go. Wow. Huh. Worked the first time. All right. It's okay if you don't fully understand this either. I mean, it will become clear when you see it again the second time. So row 0, this is always row 0, 1, 2, 3, 4, and then here's 5. So we got 1, 5, 10, 10, 5, and 1. This first one is x to the 5th. The second one, though, is 5x to the 3rd, right? Because you have negative exponents here. When it goes with this, it becomes positive. The next one here is 10x to the power of 1, because this is minus 1 times 2, minus 2 plus 3 is 1. Then you get into the negative exponents. Okay, this is 5x to the minus 3, and then this is x to the minus 5. Is that okay? Sort of? You say yes?
Wait, can you scroll back up just a little bit? Um,
Sure.
oh, okay, yeah, that makes sense. Yeah, I get it now.
So, like
Uh,
you,
so you
you,
simplified the 1 over x to
yeah,
negative. Okay, got
exactly,
it.
exactly.
Yeah.
Okay, well, have you try one, just one. Won't make it too crazy, but I'll throw this up here. Let's have you expand. Let's have you just do x minus y to the power of 4.
Mm, All right, I think I got it.
Okay. Let me write out the answer and you can tell me if you have any differences. All right.
Yeah. Oh wait, I forgot this. There. I got the x to the fourth and y to the fourth, but for the first one, I got 2x squared y to the fourth.
Okay, so
And
it should be x to the fourth minus y to the zero. And then the
oh
coefficient is one.
wait, I think I made a
You're doing
typo
this one
there.
here.
I got it now. I fixed it. I still got y or 4x squared to the fourth, and then 6x cubed y to the sixth, and then 4x squared or
All right.
x to the fourth. But
I
yeah.
miss yeah, so you got x cubed minus y to the one, and then the coefficient is
Oh,
four.
I forgot the zero. That's why.
Got to start at zero. Yeah, it's a little weird. If you're gonna do programming, it'll make more sense someday. It's a huge problem in the programming world because sometimes arrays, which are lists of numbers, index at zero, and sometimes they index at one. Were you able to look over your stuff, uh, your work there, and see if any come up with other differences?
Let's see. Oh yeah. Okay, I think you didn't do the exponent for the y's properly. That's why as well.
Easy to do. Easy to do.
I did 14641 as the exponent. Oh, right. So it goes, that's descending in the Netherlands. Yeah.
Right.
Zero.
Do you want me to give you another one to try,
Yeah.
or do you want
Yeah, we
to
can try
move on to
another
something
one.
else? Another one? Mhm. Sounds good. Do a variation on what we did earlier. Let's go 3y minus, sorry, let me go 4y minus x to the power of 3.
All right, I got my answer.
So here we go. It's minus x cubed plus 12x squared y minus 48xy squared plus 64y cubed. Now you probably have it in this order, 64y cubed.
Yeah, I think I just forgot the x squared on the 12 y.
Okay.
Yeah,
So
other
what's
than
what
that, I got
sometimes
it.
yeah, what sometimes happens is it could appear in either order depending on how you look at it, and there's not like a right or a wrong here, but it gets a little awkward with
Yeah,
X and Y,
I
especially in
did like
reverse.
the
But
bottom part, yeah.
cool. All right, so we're definitely ready for a new topic. Do you have something else you can send over for us to look at
Yeah,
today?
yeah. The next one is a little more complicated. Let me share it in chat. Alright, here's the notes for the next lesson. You can do like the problems.
It's okay. Yeah, I just need some sort of like guidance for what you guys are even doing because every book teacher is different. Your teacher does a good job on yeah. So this is end behavior graph. Um, all right, so I got to do a little lecturing and then we can move to do some problems here. Actually, let me polynomial, not a polynomial. Okay, so your teacher wants you to use this. All right. So I do it differently. There's um there's four graphs that you need to know. The first two are when the polynomial has an even power and the leading term, leading coefficient, which is called a greater than zero and a less than zero. So examples of these are like x squareds, x to the fourth, x to the sixth, x to the eighth, and so on. Now this a greater than 0 would be like a 1x squared or 2x to the fourth or 10x to the sixth. It's just positive, okay? And and the language I like is that it starts high and it ends high. And it can do literally anything in between. Like it could bounce around. Oops, I don't know why I did that. Or maybe it doesn't do much. It just comes down, it comes back up. But we only care about what's called the end behavior, where it starts and where it ends. Right? The other possibility, and this is when the leading coefficient is negative, is it starts low and ends low. And again, it could do a bunch of things in between. It could go up and it could dance around, but it eventually comes back down. Or maybe it just goes up a little, comes down, it could do a lot of things, but it eventually goes back to where it started. Have you seen any of this before?
Um,
It's okay if you haven't. I'm just sort of
yeah.
guessing. Okay. So in terms of the end behavior now, here's how we write it. So these are the same two graphs. So you write this, you say as x goes to positive infinity. And what this means when you say positive infinity, what you're saying is to the right forever. So as you go to the right forever, so what happens to the y value? Well, f of x goes to positive infinity. That's this up here. Now as x goes to negative infinity, that's to the left forever. F of x goes to positive infinity. That's over here on the left. So basically you're traversing the curve until you get to where it's just either going up or down forever.
Uh, so this would be
Okay.
going to, so the first one would be going to the right, and
Yeah.
then leaving up to the right.
Yeah. Okay. Now we can draw another graph. We can draw another graph here where I mentioned where it's going down and down. And this time, as you go to the right forever, the y goes to negative infinity. Okay. And then as x goes to negative infinity to the left forever, y, which is f of x, goes to negative infinity. So the negative infinities here refer to going down and down. So it's
Got
it's
it.
like the first part of this is left or right and then left, right and then left, and then up, up, down, down. Is that okay so far?
Yeah.
Sorry, I know this is a lot of lecturing, but there's problems are not that difficult after you get all this information down. So the other possibility is that you have an odd degree polynomial. All right, and then you got that's something like x cubed, x to the fifth, x to the seventh, leading coefficient positive. So this one starts low and ends high. So in the case of like a line, it's just a straight line, but then it could be where it goes up, then it comes down, but then it goes up again. Okay. And then the other possibility is that it's a negative leading coefficient. So if it's odd, and this one's positive leading coefficient, this is a negative leading coefficient, it goes the other way. It starts high and ends low. And again, we don't really care what's going on in the middle. Like it could do wild and crazy things in the middle here, but it will eventually get back to where it'll go the other direction. So now in terms of end behavior, redraw the graphs here. Starts low, ends high. You say something like as x goes to positive infinity, that means to the right forever. The y, f of x, also goes to positive infinity. That's the one over here on the right. As x goes to negative infinity, that's to the left forever, f of x goes to negative infinity. And if it starts high and ends low, as x goes to positive infinity to the right forever, f of x goes to negative infinity. As x goes to negative infinity to the left forever, f of x goes to positive infinity. I'm looking for a reference sheet, and first one I found I don't love. Um, but that's okay. Um, let's do some problems here, okay? Let me see if I can find teachers pay teachers. All right, parent functions. Like most things in life, you're going to learn this when you get out into the field of engineering, is that there's never something exactly the way you want, so you end up having to make it yourself, and that's okay. All right, let me put this one in the chat. This one's okay. I mean, it's not great, but it's there's worse. Okay, you ready to do some problems?
Yeah.
You don't have a choice. All right. There's a bit more to this. Okay. Um, the degree is what I've been referring to as even and odd, and you'll notice that this one has an odd, an even, and an odd there. So you choose the highest degree. So that says degree 3. The leading coefficient is the number in front of x cubed, which is 1. So the way that we've sort of been doing this is that means this is odd and a is greater than 0 and positive. So the graph of this, without knowing what else is going on, it starts low and ends high. If you look back at your notes, you'll see that. So now we can write the end behavior as x goes to positive infinity, as x goes to negative infinity. Help me fill in the blanks here. What's happening with f of x?
Mm. Positive infinity. I have actually just get you up. So
So this
positive
is the one
infinity.
going up. That's the one over here on the right.
I don't know what other one would be negative infinity.
Yes. Good. So you got to know those like 4 graphs to be able to do this. Now, the other type of problem you'll see is one where it's a bit more deceptive, which is what your teacher will probably do. So I'm gonna have to write this one. So they'll go 5x to the 4th minus 3x minus 2x to the 7th. Right. So this one is out of order, right? You need the leading coefficient, the highest degree. So you may even want to rewrite something like this as minus 2x to the seventh plus 5x to the fourth minus 3x. And then now you can figure out this other stuff. So its degree is 7, leading
Leading
coefficient is
coefficient
negative,
is negative. Then
right?
the
And the
end behavior
way we've been doing it again is that this is odd. I would always try to draw a quick sketch of it,
is what? That's
and then you can fill in, you can fill in the blanks for this.
This would be x f of x would be negative infinity for both.
For the first one, it's negative infinity, that's down.
Oh, yeah,
For
infinity
the other
plus
one, it's
infinity.
positive infinity. So that's why you got to know those four graphs really, really well. So the other types of problems that you'll see is where they give you some sort of a graph. And let's do that here. Okay, so the for degree, just tell me whether it's even or odd. Yeah, this goes up forever and this goes up forever. Tell me whether this is even or odd and whether the coefficient is positive or negative.
The even
It is even. Now, is it positive or negative leading coefficient? And what you're trying to decide is, like this is this is the reference
uh, leading coefficient would be positive.
is positive, yeah. And then the end behavior here is x goes to negative infinity, positive infinity, negative infinity. What does y go to?
Positive infinity.
Yeah, good. Right, good job. Okay, so that is going to do it for us for today. I think we got a lesson scheduled for tomorrow. There's more to pick up on here, so we'll just stop the